Hello everyone and welcome to our presentation about our Lifi-based project called LEPS, or Lifi Enabled Protection System. Let's discuss what the contemporary issues our project will be targeting. Our main priority with LEPS is to decrease the slightly increasing rate of accidents in the UAE and hopefully in the future around the world. To work on our issue, we first have to understand what are the causes of the accidents. As you can see, one of the top causes is sudden lane change, which someone might do to avoid an accident themselves. The other reason is driving without keeping a safe distance. What this really means is that the driver failed to brake in due time to perhaps an unexpected emergency. Our communication system can help them achieve the goal of enhancing emergency preparedness, reliability of police services, and road safety stipulated in the UAE Vision 2021 launched by His Highness Sheikh Mohammed bin Rashid Al Maktoum, Vice President and Prime Minister of the UAE. We all know for certain the future will depend on self-driving cars powered by AI who can assess situations better than us humans. We are the youth of the future, so the future starts with us. Our LEP system will be one of the first steps we take into stepping into the future by creating smart cities where the environment interacts with the population. The other major benefit would be the reduced power consumption of the outdated current streetlights.
So what is Li-Fi? Li-Fi is a bidirectional wireless communication that utilizes light to transmit data between devices. Li-Fi is a light communication system that is capable of transmitting data at high speeds over the visible light and infrared spectrum. The use of LED lamps eliminates the need for complex wireless networks and protocols. Since we can control the current flowing through the LED, we generate binary data by flickering the lights at speeds which are unseen by human eye. The operation procedure is very simple. If the LED is on, we transmit digit 1, and if it's off, we transmit digit 0. By varying the rate at which the LEDs flicker, we can encode the data the way we want. Every LED light source can work as a hub for data transmission, as long as we have a controller or a Li-Fi module attached to it. Other applications of Li-Fi include, but not limited to, intelligent transportation systems, safety environments, underwater communication, and security. The project on the left-hand side is based on creating a small-scale prototype of vehicle-to-vehicle communication system using Li-Fi technology, a new technology that was developed in the last few years. We still need more investigation on its sustainability for outdoor vehicular networks. The project on the right-hand side is based on developing a smart street light system. In this project, the street light system in which lights on when needed and 40% light intensity when not needed. Abu Dhabi already announced the completion of its planned lighting maintenance project, where they will replace more than 4,000 traditional streetlights with modern energy-saving LED lights. The authorities have stated the $3 million development can contribute to more than 80% of savings in annual energy consumption, while also reducing the road lighting maintenance and raising the level of road safety in Abu Dhabi. The high-pressure sodium lamp is the most commonly used street light throughout the world. It produces light by running electricity through a mixture of gases, which produces light. These lamps are somewhat efficient. They take a while to turn on completely and produce a yellow-orange glow. However, LED technologies have developed rapidly in the recent years, and these lamps are now being integrated into outdoor lighting solutions due to its significant energy-saving property. This is the simplest form of explanation of what our project does. As you can see, we first receive the road information, then encrypt it into light, which is then transmitted via Li-Fi. The receiver decrypts the message and receives information. The information is then displayed for the driver and sends alarming messages.
Let's jump straight into the design implementation. This prototype has two parts. One to demonstrate the streetlights, or the transmitter part of the system, which also includes the button of which the data will be sent according to what is pushed. The other part is the vehicle, or also known as the receiving parts of the system. Inside that, we have the receiver module of the Li-Fi or the solar panel, and the screen, which is responsible for displaying the translated light into understandable commands for the users. Both parts are controlled by Arduino microcontroller, which manages the processes and controlling the system according to the codes we made using C language. The prototype is a simulation of a road with two streetlights that can broadcast the encrypted messages via Li-Fi and will be received by vehicles that have the receivers on them to decrypt the transmitted information and display them for the drivers in order to know the condition of the roads ahead of them. Furthermore, the drivers can request assistance in case of an emergency by pressing the SOS button, which will send an SMS message to the local emergency responders with the exact coordinates of where the button was pushed. By doing so, you would remove the need to unlock your phone amidst an emergency and have the emergency responders come to you as soon as possible. This is the block diagram of the base or the transmitter that is responsible for sending information using the streetlight to the vehicle. The heart of the system for transmitting parts is the Arduino, which controls the processes of the project as it receives the input from the push buttons for each of the hypothetical cases, such as fog or accident or even traffic. According to the push button, the controller will send information encrypted within the lights. To power the system, we are using a 12-volt battery since the Lifi module requires a 12-volt to operate. In order to avoid using two separate power sources, we added a 5-volt step-down voltage regulator to power the Arduino and other electronics connected to it. For the receiving parts of the system, or the vehicle, the block diagram shows the basic connections of the system. Similar to the other connection, this one is also centered around the microcontroller and has items connected to it. The receiving parts of the Li-Fi module also requires a 12 volt, hence they are connected with a battery, and the step-down converter is replaced to get the 5 volt for the Arduino. In this circuit, we are connecting a 16x4 LCD display screen that shows the received information, and the GPS module which gets the coordinates of the location, and the GSM module is connected to the controller to send the SMSs that contain the alarming messages and the emergency push button as well. Here's a live demo of our project. So this is the entire project. As you can see, we got the base station over here with the 3 push buttons to simulate any type of situation. You got the street lights over here, 1 and 2, and this is the car or the receiving station with the 16x4 LCD screen, the emergency push button, and the solar panel to receive the messages from the light shining from above. You have the charging ports, the on and off buttons for the receiving ports, and same thing for the base station, on and off charging ports. Let's take a look inside. You have the GPS and you have the GSM located over here. We have the SIM card installed here, so we can send and receive messages. You got the microcontroller down here, the battery, and yeah, pretty much that's what it looks like from the inside. The GPS is not on, it's not connected, because this green light, I'm going to try to show you, this light over here, this is supposed to turn on and off. It'll flash when it's connected, but because I'm indoors and the GPS is not connected, like it's really hard to detect the signal while you're indoors. But once like we get to the part where we demonstrate sending the message, I'm going to take the receiving box, take it outside the window just until it connects, so we can send the message. So let's say we put the car or the receiver inside here. Okay. Right now it's off. Let's see what happens if we push the fog button. You'll instantly get a warning, the warning fog, because we pushed the fog button. The lights transmitted to the receiver and we received the warning, as you can see. Let's turn this back off. Perfect, it's off. Let's go to the accident button. See, right now, no display, nothing. Once you push the accident button, instantly you get the warning through the lights to the car. Let's turn this back off. Should go away, perfect. And now the traffic button. Within a second, you get the warning message, perfect. Now, this is gonna be hard to show you, because I need to flip this. Okay, it's quite simple. You have the, what do you call it, the power supply connected over here. You have the this went loose, but this is supposed to be hot glued onto the side over here. This is the Li-Fi module that we got from India. One for each light post, or street light, sorry. And of course the microcontroller, and you have the 3 push buttons over here on the side. The on and off switch. What else can I show you? Oh, that's the step down regulator, the 5-volt step down regulator for the microcontroller. Because like I said in the PowerPoint, this is 12 volt, 5 volt for the Arduino Mega. And you have some design. Yeah, that's pretty much it. There's not much to it besides that. I think that covers everything. Have a good day. So just to show you that the SOS is working, the GCM and the GPS, I've taken the receiver outside so that the GPS can connect, and as you can see it's flashing green, so that means it is connected. Let's quickly push the SOS button and wait for the message. There you go. We just got the message within like a few seconds, not even 5 seconds. We click the link, you get the coordinates exactly of where you push the button. Thank you very much.